Good evening. Exercise 8.1, question 9. Which of the following functions have a removable discontinuity? If it has a removable discontinuity, redefine the function so that it becomes continuous. We'll be doing second part. Third, we have already discussed. Second is f of x equal to log of 1 plus 5x to the base 1 plus 3x for x greater than 0. And 32 raised to x minus 1 upon 8 raised to x minus 1 for x less than 0 at x equal to 0. Okay. So limit extends to 0 plus. For that, we have to consider which function? Log of 1 plus 5x to the base 1 plus 3x. Now, change of base. Log a to the base b is log a to the base e upon log b to the base e. The only thing is I will not mention the base because in calculus, it is customary not to mention the base of logarithm if it is e. So log of 1 plus 5x upon log of 1 plus 3x. What next? See, divide by x, but here it is 5x. So I have written 5x. So into 5 in the numerator. What about denominator? 3x. So into 3. Now 5 by 3 is constant. Outside the limit. Limit of quotient is limit of numerator upon limit of denominator. Now this is standard limit. Its value is 1. I'll mention the reason also. So this is nothing but 5 by 3. You have to mention this as x tends to 0. 3x and 5x both tend to 0. Limit y tends to 0. Log of 1 plus y upon y is 1. Now this limit is simple one. Divide numerator and denominator by x. Value of this limit is log 32 upon value of this limit log 8. I hope you won't say log 32 by log 8 is 4. No, 32 is 2 raised to 5. Log of m raised to n is n log m. So 5 log 2 upon 3 log 2. So this is nothing but 5 by 3. After this, we have to say this is equal to limit x tends to 0 plus fx. Left hand limit is same as right hand limit. Right? Therefore, I will just say limit x tends to 0, f of x comes out to be 5 by 3. Now, can we conclude that function is continuous? No. Why? We have to mention the reason. F of 0 is not defined. See the given function. F of 0 is not defined. Therefore, f is discontinuous. Discontinuous at x equal to 0. Okay, what about type of discontinuity? This is removable because limit exists. This is removable. Therefore, or I will say we define function as follows. To make it continuous. Right? So f of x is nothing but log of 1 plus 5x to the base 1 plus 3x for x greater than 0 equal to 32 raised to x minus 1 upon 8 raised to x minus 1 for x less than 0 and equal to 5 upon 3 for x equal to 0. Fourth one, f of x is 3x plus 2 for minus 4 less than or equal to x less than or equal to minus 2. It is 2x minus 3 for minus 2 less than x less than or equal to 6. Now limit extends to minus to minus. Now you may ask why to select minus 2? Because domain is temporarily broken at minus 2. For minus 2 we can have left hand limit and right hand limit. So limit extends to minus. I hope you won't say minus plus. Yes, minus is plus only, but in case of product, here this means minus means to the left of minus 2. So for that we have to consider 3x plus 2. What is the value? Evaluation of limit is simple. Replace x by minus 2. So minus 4. What is limit extends to minus 2 plus right hand limit? For that, which function is to be taken? 2x minus 3. So 2 into minus 2 minus 3, that is minus 7. Not the same as left hand limit. So limit does not exist. So function is discontinuous at x equal to minus 2. Now this discontinuity is irremovable. Why? Because limit does not exist. Fifth one, f of x is x cube minus 8 upon x square minus 4 for x greater than 2. It is 3 for x equal to 2. And it is e raised to 3 into square of x minus 2 minus 1 upon 2 into square of x minus 2 for x less than. Okay. Let us find right hand limit first. Limit extends to 2 plus fx. First part is simple. What are the factors of x cube minus 8? X minus 2, other factor, please don't say x square plus 4x. It is x square plus 2x plus 4. A cube minus b cube has factors a minus b, a square plus ab, not twice ab, a square plus ab plus b square. What about denominator? X minus 2, x plus 2. Cancel x minus 2. Take the limit. So the value of right hand limit comes out to be 3. Actually, evaluation of left hand limit is also not difficult. You will notice that index tends to 0 and is almost fully repeated in the denominator. The only thing is you have to write this as 3 by 2 into this upon 3 into. Why? Because if index tends to 0 and is fully repeated in the denominator, value of the limit is 1. Have we written the same function that is required? Yes, we have. Effectively 3 gets cancelled, half. Yes, only 1 by 2 is present. So the value of limit comes out to be 3 by 2, which is not the same as limit extends to 2 plus. This means limit does not exist. As limit does not exist, function is discontinuous, and the type of discontinuity is jump discontinuity, that is irremovable discontinuity. Our 10th one, we'll be doing second part. If f of x equal to cos square x minus sin square x minus 1 upon root of 3x square plus 1 minus 1 for x not equal to 0 is continuous at x equal to 0. Find f of 0. Simple one. Function is given to be continuous. So f of 0 must be equal to value of the limit. Now evaluation of limit, for that numerator is cos square x minus sin square x minus 1. You may say cos square x minus sin square x is cos 2x. Yes, but that will not help. Write cos square x as 1 minus sin square x. So that gives you minus 2 sin square x. You have to realize that you have to rationalize denominator. That is multiply numerator and denominator by root of 3x square plus 1 plus 1. So that gives me minus 2 sin square x into in bracket 3x square plus 1 upon 3x square plus 1 minus 1. That is just 3x square in the denominator. Here actually I have omitted one step. You have to say limit of product, product of limits, and then limit of square is square of limit. Now this is standard limit, its value is 1, so 1 square. Now what about this? To take limit means to replace x by its limiting value, which is 0. So minus 2 by 3 into 1 square into 2. So minus 4 by 3 is the answer. The first one is again simple one, that is for homework. Here you have to realize that you have to rationalize numerator. That is multiply numerator and denominator by root of 2 plus sin x plus root 3. And denominator cos square x is to be written as 1 minus sin square x. What are the factors? 1 minus sin, 1 plus sin. What is sin pi by 2? 1. So this is the answer. Minus 1 upon 4 root 3. Fifth one, let me read the sum for you. F of x is, this is x cube minus 8 upon x square minus 4 for x greater than 2, equal to 3 for x equal to 2, not minus, x equal to 2. And e raised to, have we done this? Yes. I think we have. Oh, we have done this. Okay. Fifth one we have already solved. Right? Yes. Third one, f of x is 4 raised to x minus pi plus 4 raised to pi minus x minus 2 upon square of x minus pi. For x not equal to pi, it's continuous at x equal to pi. Find f of pi. Pi. Okay. Now f is given to be continuous at x equal to pi. So by definition, what is f of pi? Value of the limit. Now evaluation of limit is not at all difficult. We have to put x equal to pi plus h. As x tends to pi, h will tend to 0. So this is limit h tends to 0. X is pi plus h. So it is x minus pi h. And it will be very careful. What will be pi minus x minus h? Now 4 raised to minus h is 1 upon 4 raised to h. Find LCM and simplify. So you will notice that this has become square of 4 raised to h minus 1. 4 raised to h goes in the denominator. So this is now limit of square of limit. Value of this limit is log 4. So log 4 square, what is 4 raised to 0? 1. I hope you won't say log 4 square is 2 log 4, but you can say log 4 is log of 2 square. So 2 log 2. Square of that is 4 square of log. In exam for this also you will get full marks. 11th, first one, if f of x is 24 raised to x minus 8 raised to x minus 3 raised to x plus 1 upon 12 raised to x minus 4 raised to x minus 3 raised to x plus 1 for x not equal to 0, and its k for x equal to 0 is continuous at x equal to 0. Find k. Okay. Now function is given to be continuous. So f of 0, which is k, must be equal to value of this limit. Now how to evaluate limit? What can be done here? 24 is 3 into 8. Now ab raised to x is a raised to x, b raised to x. That is why I have directly written 24 raised to x as 8 raised to x into 3 raised to x. Remaining terms as they are. In the denominator, 12 raised to x, 12 is 3 into 4. So 3 raised to x into 4 raised to x. Remaining terms as they are. Take 8 raised to x common from first two terms. Take minus 1 common from remaining. In the denominator, take 4 raised to x common from first two, minus 1 from remaining two. Now, can I divide numerator and denominator by this? You may say, can we take 3 raised to x minus 1 common to get 8 raised to x minus 1 in another bracket? Same thing. I have directly divided. Division is allowed, valid, because x only tends to 0. So 3 raised to x minus 1 is non-zero. So division is allowed. Now, this is not standard limit. So you have to divide numerator and denominator by x. Of course, we have to mention the reason that division is valid because x only tends to 0. X is not equal to 0. Limit of quotient is limit of numerator upon limit of denominator. So this is log 8 upon log 4. This can be simplified further. I hope you won't say this is 2. because what is log 8? It is log of 2 cube, and what is log 4? Log of 2 square. So this is 3 log 2 upon 2 log 2. Now cancel log 2 to get 3 upon 2. So what must be the value of k? 3 by 2. Second is again a simple one. 5 raised to minus x is to be written as 1 upon 5 raised to x. So effectively function is 5 raised to x minus 1 square upon 5 raised to x into x square. Now value of limit is square of log 5 given to be continuous, so k must be square of log 5. Third sum is important. F of x is sin 2x upon 5x minus a for x greater than 0 equal to 4 for x equal to 0 equal to x square plus b minus 3 for x less than 0 is continuous at x equal to 0. Find a and b. Now f of 0 is going to be 4. Number 1. Limit x tends to 0 plus fx is limit x tends to 0. For 0 plus means greater than 0, we have to consider this function. Sin 2x upon 2x we need. That is why I have directly written 2 by 5. We have written the same thing but in required form. Limit of constant is constant. Now we have to mention the reason that as x tends to 0, 2x tends to 0, and this is standard limit. Its value is 1. So what is right hand limit? 2 upon 5 minus a. Limit x tends to 0 minus fx is limit x tends to 0 minus x square plus b minus 3. Take limit in the first step. So that gives me value of the limit as b minus 3, left hand limit. Function is continuous at x equal to 0. So limit x tends to 0 minus fx is f of 0 is limit x tends to 0 plus fx. So b minus 3 equal to 4 equal to 2 upon 5 minus 8. That gives me a as minus 18 upon 5. And what is b? 7. 11th sum, fourth part. For what values of a and b is the function f of x equal to ax plus 2b plus 18 for x less than or equal to 0 equal to x square plus 3a minus b for 0 less than x less than or equal to 2 equal to 8x minus 2 for x greater than 2 is continuous for every x. Now f is continuous for every x, so it must be continuous at 0 and 2. Now you may ask why 0 and 2? For the simple reason domain is temporarily broken at 0 and 2. And to get the values of unknowns, we must be able to write two equations. And to get an equation, we have to find left hand limit and right hand limit. And it can be obtained for 0 and 2. I hope this is clear to you. Okay. So after this, continuity at x equal to 0. Limit exists, so left hand limit must be same as right hand limit. For right hand limit, we have to consider which function? See, x greater than 0. So this function. For left hand limit, the first one. I already told you that evaluation of limit is not at all difficult. The concept of continuity, again, it is not difficult, but if the concepts are clear, then only we will be able to choose these 2 points, equate left hand limit with right hand limit and so on. Now, first equation is a minus b equal to 6. Okay. Function is continuous at 2 also. So left hand limit same as right hand limit. Now for 2 plus means greater than 2. Which function is to be taken? 8x minus 2. And for left hand limit, this one. Okay. Yes. So f is continuous at x equal to 2. Limit x tends to 2. Fx exists. Right hand limit same as left hand limit. So we get value of a directly in this case. A comes out to be 2. So put a equal to 2 in 1. We get b equal to minus 4. Fifth one is for homework. A is 2 and b is minus 4. Sum number 12. Discuss the continuity, not continuous, continuity of function f on its domain where fx is mod of x plus 1 for minus 3 less than or equal to x less than or equal to 2 equal to mod of x minus 5 for 2 less than x less than or equal to 7. Clearly domain is closed interval minus 3 to 7. Of course, it is temporarily broken for rather at 2 because this is piecewise function. Now, modulus function is always continuous on R, set of real numbers. So ideally we should write function is continuous on R and therefore on closed interval minus 3, 7 except possibly at 2. Why to say so? Because for 2 we have to find left hand and right hand limits separately, right? That is why I have written, but here we have to discuss continuity at x equal to 2. Find out left hand right hand limits. Now f of x is mod of x plus 1 for minus 3 less than or equal to x less than or equal to 2. So we have to select this function to evaluate f of 2. It comes out to be mod of 3, that is 3. Now limit extends to 2 minus. For that we have to consider which function? Mod of x plus 1. So mod of 2 plus 1, mod 3 is 3. For just a minute. The first one was left hand limit. Now 2 plus. So this is right hand limit. Limit extends to 2 plus. 2 plus means to the right of 2 greater than 2. For greater than 2, we have to consider mod of x minus 5. Put x equal to 2. Mod of minus 3 is again 3. As limit extends to 2 minus fx is f of 2 is the same as limit extends to 2 plus fx. Function is continuous at x equal to 2. So finally you have to write, so f is continuous on its domain minus 3, 7. Because at other points function is definitely continuous. So we are worried about 2. Why? Because at that point domain is temporarily broken. So left hand and right hand limits are to be evaluated separately. They need not be equal. Here they are. And each is same as f of 2. So function is continuous at 2. Therefore, it is continuous on its domain closed interval minus 3 to 7. So that's it for today.